Okay, Assalamualaikum and selamat sejahtera. So now we proceed to the next topic, which is oxygen dissociation curve. Okay, so first of all, what is oxygen dissociation curve? So oxygen dissociation curve will be represented by this graph. Okay, so if you look at this graph, it is the graph of oxygen saturation of hemoglobin or percentage oxygen saturation of hemoglobin against partial pressure of oxygen. Okay, so what is the meaning of oxygen saturation of hemoglobin? So this one, actually we look at the percentage of oxygen bind to the hemoglobin against the partial pressure of oxygen. Okay, so what is oxygen dissociation curve? So how to explain oxygen dissociation curve or ODC? It is based on this point lah. Okay, so first of all, ODC will show amount of oxygen bound to hemoglobin at different PO2. So PO2 here refers to partial pressure of oxygen. So the unit for partial pressure of oxygen is mmHg. Okay, so kalau kita tengok dari segi, okay, percentage oxygen saturation of hemoglobin, okay, if you look at this graph, so for ODC, it will show sigmoid shape or the curve is sigmoid. Sigmoid means the curve is S-shaped. Okay, so based on the characteristic of hemoglobin, hemoglobin has high affinity for oxygen. So the higher the partial pressure of oxygen, the higher is the percentage of oxygen saturation in hemoglobin. So that's why kalau awak tengok based on this graph, the higher the partial pressure of oxygen, so what happened to the percentage oxygen saturation of hemoglobin, it will be high. Okay, then at very high partial pressure of oxygen, so usually very high partial pressure of oxygen is at the lung. So what happened? Hemoglobin is very saturated with oxygen. So kalau kita tengok dekat sini, okay, look at this graph. So at lung, the partial pressure of oxygen is very high. So let's say at lungs here, the partial pressure of oxygen is 100 mmHg. So what happened to the percentage oxygen saturation of hemoglobin? It will be the highest. So blood can be saturated with oxygen up to 98% at lung. So maksudnya dari segi percentage oxygen bind to the hemoglobin is the highest at the lung. Okay, because of what? Partial pressure of oxygen at the lung is very high. Okay, then when partial pressure of oxygen decrease at respiring tissue, so what is the meaning of respiring tissue? Means that tissue that undergoes cellular respiration. So once tissue undergoes cellular respiration, so it will produce carbon dioxide. So bila carbon dioxide tinggi, partial pressure of oxygen akan decrease. So what happened to the oxyhemoglobin? So the tendency of oxyhemoglobin to release oxygen is greater because of what? Hemoglobin has lower affinity towards oxygen. Okay, lower affinity means kecenderungan hemoglobin terhadap oksigen adalah rendah bila sahaja partial pressure of oxygen decrease, terutamanya pada respiring tissue. Ingat, respiring tissue means that the tissue will undergo cellular respiration, so it will produce carbon dioxide. So bila carbon dioxide tinggi, partial pressure of oxygen akan rendah. So what happen to the tendency of oxyhemoglobin to release oxygen is greater. Maksudnya pada keadaan ni, hemoglobin adalah lebih senang untuk riliskan oksigen because of what? Hemoglobin has lower affinity to oxygen. Okay, and then so when partial pressure of oxygen decrease, the percentage of oxygen saturation in hemoglobin also decrease. Okay, so kita boleh compare di sini. This one represent tissue at rest. So at tissue at rest, the partial pressure of oxygen is around 40 mmHg. So what is the percentage of oxygen saturation to hemoglobin is around 75%. Tapi bila kita compare dengan tissues during exercise, so let's say tissues during exercise, the partial pressure of oxygen is around 18 mmHg. So the percentage oxygen saturated to hemoglobin is only 18%. So 18% is very low. Kenapa? Because of what? At this time, oxyhemoglobin has a greater tendency to release oxygen. Kenapa dia akan greater tendency to release oxygen? Sebab pada keadaan ni, carbon dioxide adalah tinggi. So oxyhemoglobin akan riliskan oxygen. Okay, so untuk memudahkan kefahaman awak, so kita ambil contoh this diagram. Okay, so in active tissue, what happen? Active tissue means tissue that is in high metabolic. Okay, so it will undergo rapidly cellular respiration. So what happen? Carbon dioxide concentration will be increased. So since carbon dioxide concentration increase, so what happen to the partial pressure of oxygen? It will be decreased. Okay, so sebelum ni kita dah discuss berkaitan dengan transportation of oxygen. So what happen to the carbon dioxide? Carbon dioxide will react with water and it will form carbonic acid. So once carbonic acid is already produced, it will be dissociated into hydrogen ion and also bicarbonate ion. So if carbon dioxide concentration increase, okay, so apa yang akan berlaku? Secara langsungnya, hydrogen ion yang terhasil pun akan jadi tinggi. So apa yang akan berlaku adalah bila berlaku increasing in hydrogen ion, it also will increase the acidity of blood. So once acidity of blood increase, so what happen to blood pH? Blood pH will be decrease. Okay, so what happened to oxyhemoglobin? So kita tahu oxyhemoglobin actually it is a combination in between oxygen and also hemoglobin. Means that bila oxygen bind kepada hemoglobin, so it will form oxyhemoglobin. So dalam keadaan carbon dioxide yang tinggi, so what happened to oxyhemoglobin? It has greater tendency to release oxygen. So daripada oxyhemoglobin, when it is dissociate, so it will become oxygen and also hemoglobin. Kenapa perlu riliskan oksigen? Sebab pada tisu during exercise, partial pressure of oxygen adalah rendah. So oksigen ni diperlukan untuk cover balik oksigen yang telah digunakan. And also hemoglobin ni sebenarnya dia akan digunakan untuk once hemoglobin is released. Okay, so this hemoglobin will combine with hydrogen ion and it will form hemoglobinic acid. So actually this one dia relate dengan apa yang kita dah discuss sebelum ni. Kenapa hemoglobin perlu bind kepada hydrogen ion? Okay, to prevent the blood from becoming acidic. Okay, so what happen? This will cause affinity of hemoglobin towards oxygen to be decreased. Okay. So macam mana kita nak fahamkan konsep ODC? Kita boleh refer kepada this graph. Okay, so firstly you have to know ODC will show the sigmoid shape. Okay, and then some of the question dia akan bagi the partial pressure of oxygen in 3 different locations. So for the example, based on this graph, we have partial pressure of oxygen in lung, tissue at rest and also during exercise. So bila kita buat comparison, bila partial pressure of oxygen tinggi, okay, especially in lung, so what happen? The percentage of oxygen saturated to hemoglobin also will be increased. So at lung, percentage oxygen saturation of hemoglobin is up to 98%. So 98% tu adalah sangat tinggi. Okay. Tapi kalau kita compare dengan tissues during exercise, since partial pressure of oxygen at tissues during exercise adalah rendah, so that's why the percentage oxygen saturation of hemoglobin juga adalah rendah. Okay, and then one more thing, you have to know the oxygen unloaded. Okay, oxygen unloaded means oxygen that will be released from the hemoglobin. So kalau kita compare di sini ada dua. The first one is oxygen unloaded to tissues during exercise and also oxygen unloaded to tissues at rest. So where does this comes from? So yang ni kita tengok dari segi, this one is the oxyhemoglobin in the lung. Okay, so tissues during exercise is here. Okay, so the percentage of oxygen saturation of hemoglobin at lung is 98%. But the percentage of oxygen saturation of hemoglobin at tissues during exercise is 18%. So macam mana kita nak calculate oxygen unloaded to tissues during exercise? So daripada sini sampai sini lah. Okay, so how to calculate? So to get the percentage oxygen unloaded to tissues during exercise means that 98%, okay, minus 18%. So you will get 80% of oxygen will be unloaded to tissues during exercise. Maksudnya 80% tu adalah sangat banyak lah. Okay, sebab apa? Tissues during exercise, dia punya partial pressure of oxygen adalah rendah. Okay, and then kalau kita nak calculate percentage of oxygen unloaded to tissues at rest, okay, so here is 98%. So percentage oxygen saturation to hemoglobin at tissues at rest is 75%. So 98% minus 75%. So the answer is 23% of oxygen unloaded to tissues at rest. Okay, so this kind of question actually you can refer to your booster. Okay, so this is about ODC. So means that you have to take note, okay, the important points about oxygen dissociation curve, and also you have to take note macam mana kita nak explain oxygen dissociation curve. Okay.